Hello everyone. So today our topic is about creating an AI assistant and having a real-time communication with it. For this purpose, I'll be using Flutter WebRTC and OpenAI real-time API. So first, let's look into that. So I'll be using the API from OpenAI and this package Flutter WebRTC. So let's get started. Okay, so this is a new project, and in here, what I want is that I want to like first add up the required packages. So the first one is this Flutter WebRTC. So I'll add this up, and the next I want is the HTTP package. I'll just press save, and it has imported that. So in here, I'll create a screen. In here, I'll just create a screen, or I'll just create a file as OpenAI server dot. Okay, so in here, what I want to do is that I want to basically connect to the OpenAI service. So I'll just copy the boilerplate code and use it as it is. So in here, in the in the API key, in place of that this API key, we need to add our own API key. So how to get that API key? So for that, we will have to go to the OpenAI, and in here, for it will ask you first to tell him about the organization, and then you can create a project, and from there onward you can start with it. So basically, to get my API key, I'll need to go into your profile, and here the API keys, and currently I don't have any API key, so I'll just click on this, and I'll just let it as test key, create secret key. So it's here, I can just copy it, done, and this is my secret key. And as you can see, it shows last used never. So this part is done, and I can just paste it over here. I'll remove this API key from the backend from the OpenAI service after the video is ended. So there's no need, and there's no like point in using my API key because it won't be of any use. Okay. Other than that, what I want is I want to use the real-time API, basically the real-time API from OpenAI, and I've like pointed out what model do I want, the GPT-4o real-time preview. So this is the latest as of now. At the time of this video, like when the video is being made, this is the latest version of it. Okay, so this is saved. Now let's move to our screen. So main screen dot dot, and this will be a stateful widget. Main screen. Okay, so currently I've made this UI, and I'll run this on my emulator as well. So meanwhile my emulator is opening, I can create a function over here. So the function name will be basically to start the WebRTC session. So I can say like future void start WebRTC session. Okay, so this will be in the try catch block. Okay, so at first what we want is that I want to get my empirical key. So when this function get runs, this get empirical token returns an empirical key. So I need to use that. So I'll create a variable over here. Get empirical token. Okay, so this will be a wait because that's a future. So this is done. I'll comment it as well. Okay, so we've got the key. The next thing we want is um, we want to create a configuration. Uh, Also, I can print that empirical key. So I can say something like key generated, and the key is this, like the key. Okay, so the next thing I want is like I want to create a configuration. So basically I want to populate the peer connections, the servers and all. So for that I'll create a map. Sorry. So I can name it as final configs. Okay, and the final configs will first take ICE server, and it will take a list of servers. So the list will be of the type like of a map, and the map will contain the URLs. So the URLs, and the URLs will again be a list. So I can just use stan1 dot 1 dot google.com 19302, and I can use one more server like that, one more URL like that, and it will be stan 2.1. So the configuration is done. The next thing I want over here is I want to give the SDP semantics. So semantics, and for this we will give unified plan, and one last thing over here is enable DTLS start TP. So we give it as true. Okay, so the configs is done. And now the next thing I want is I want to create a peer connection with these configs. So I'll create a variable at the top. It will be an RTC peer connection, and this will be lake peer connection. Peer connection is equals to await create peer connection, and for this I'll create another function, or we can just like use this same function to create a peer connection, and in place of the configuration I can just give the configs. Okay, so now this is done. The next thing I want is that I want to check if the peer connection was made. So it can be null as well. So one thing I can do is, instead of making it late, I can make it nullable. So I can check that after the create peer connection runs, is the peer connection successfully made or not. So peer connection does not equals to null, or I can just check that if it's equal to null, I can throw an exception over here, and the exception can say something like uh, failed to create peer connection, right? So we have checked that if the connection was successfully made or not. Okay, the next thing I want over here is that I want to basically use the ICE servers, and I can confirm, like basically add a candidate, so an ICE candidate that will listen to the changes on the peer connection. So to do that, I can make it something like peer connection. It can be nullable, so check on ICE candidate is equals to candidate, and I can make it async. Okay, it will be an async function, and in here what I can do is I can print, first of all, um, got the ICE candidate, and then I can also print the candidate, so candidate dot candidate, and I can print this. The next thing I can do is I can also check that if, or I can just simply go over here because I've just used null check operator, so it won't work. Okay, so in here I can check is, what I can do is candidate dot candidate does not equals to null, and peer connection does not equals to null. So when there is they aren't, the both are not null, then what I want to do is in a try catch block I will add the candidate to the peer connection. So await peer connection, and peer connection dot add candidate, and the candidate is provided above. And in here I can print if there are any errors. So error adding candidate to the peer connection, and I can just simply print that as well. Okay, so now that is done. The next thing I want is that I want to check and maintain the states of the peer connection, basically the call. So for that I can use peer connection dot connection state, use this. So is equals to, same like the candidate, I'll use state, and this will be on connection state. Okay, so in here I'll get the state. So if state is equals to RTC peer connection state dot RTC peer connection state failed. So if it's failed, or I can just copy that same line and paste it in here, and I can check that if the state is closed, state closed. So if the state is closed, then I'll stop the RTC connection. So I can just make the function over here, and then I will use this function when I'll need it. So this is start WebRTC connection. I can just make it as stop WebRTC connection. Okay, so I can just copy this function over here and just start. Okay, so other than that, what we can do is that we also need to add the media constraints, and basically how and the media of the call should be handled. So for that, I'll create a simple map just like this for the configs, and here I'll name it as media configs, and we don't need this. In here we have to pass the things we need to do for audio. So for audio, what I need is I want echo cancellation, and I need this to be true. I want noise suppression and auto grain control, and auto grain control. You can also set it to true, but what I've noticed is that when it's on, there is a lot of distortion from the mic, so that's not worth it. But it can work for some people for some use cases. And for the video, as we are only having a chat with the AI, so we don't need the video for this, and I'll just make it as false. Okay, now I want to pass these media configs to our local stream. So basically the local stream is the stream that is handling our current data. So I'll go in the top, and in here I'll make a variable as media stream, and it will be local stream. Okay, and I'll just pass my data, my media configs, to the local stream. So in here I'll do it as local stream is equals to await, and it will be navigator. So basically we will use navigator from our package, the WebRTC package, navigator dot media devices dot get user media, and in the get user media I'll pass the media configs. So this is done. We have passed the type of data that we want and how we want it. So this is done. And the next thing I want is that we will check the state of our peer connection, and if the peer connection state is not closed, it means that there's an ongoing call. So we will add the track, the local stream. Basically we will get the tracks from the local stream and then pass it on to the peer connection so that it can communicate with the real-time API. So for that, what we will do is if peer connection is not equals to null, and also I can pass a check in as peer connection state, peer connection dot state, sorry, dot connection state is equals to, or we can just simply check does not equals to RTC peer connection state dot close. So if it's not closed in that particular case, what I want to do is that I want to move forward and add the local stream to the peer connection. So I'll iterate over the local stream. So I'll get the local stream dot get tracks, and for each track I want it to add the track in the peer connection. So in the peer connection dot add track, and in here the track, and I'll also pass the local stream. So the local stream is added, it can be null, so I've added this. Okay, so now we have successfully added the local stream, and it's working perfectly. So the next thing we want to do is we want to create a data channel, and this data channel will be responsible for handling the events between the API and the user. So basically it will be a bridge between the device and the OpenAI servers. So to get that, I'll just simply use an RTC data channel. So first of all, I'll make a data channel variable. So I'll go to the top, and here I'll create RTC data channel, and it will be data channel. Okay, so okay, so first of all, I'll create the initial properties for the data channel. So it will be RTC data channel init, and is equals to RTC data channel init, and I'll just use the short form, the ordered to true, sorry, and no, we actually don't need this either. Max retransmits, and this can go to 15, or let's say we can just make it 30, and the protocol will be SCTP, and negotiated is false, equals to false. So the properties are created. Now we can just create a data channel using the peer connection. So it will be data channel is equals to await peer connection dot create data channel, and we can just pass the data channel in it over here, and we can pass a label as well. So the label will be events, or we can just say OAI events. Okay, so okay, so this is done. The next thing we want is that we want to create and like set a local description for the specific constraints that we want on our user side as well. So I'll create the same configs over here. This will be offer options, and what we want over here is offer to offer to receive audio You can set it to false or you can set it to true, it's up to you. And in here I want to receive video. I don't want it as I want the audio to be true, but I don't want the video. So this, and then voice activity detection. So for example, it will keep the mic on and it will listen to anything that is set to the user, sorry, the API. So it will directly send it and get the answer processed. So the next thing we want is the RTC session description, and this will be an offer. Okay, and this offer is equals to await peer connection dot create offer, and I'll use the offer options. Okay, so this is done, and then when my offer is created, I can use my peer connection function, sorry, variable, and through the peer connection I can set my local description for this. So I will use await peer connection dot set local description, and this will be the offer that was just created. So this is completed. Now what I want to do is I want to send the response, the process thing, to my backend, so basically the API. So for that I'll use this code, and this code will be responsible for getting the answers processed. So after setting the local description, I can just move forward and create the send the response to the backend. So this, for that, uh, I'll be using the HTTP package. So in here I'll import the HTTP package. Okay, so I've imported it. We'll use the infidel key that we created at the top. So I'll just copy it, paste it in here, and can be unconditionally null, so I can just use this, and then I'll remove the underscore for the peer connection, and in here okay, so one of my variables is having a problem, so this catch, okay, I need a variable for here. So this is the try block. This is, okay, I'll just copy the complete code for this. So after the remote description, we actually need this peer connection, and I can just remove this, as of now. And the stop WebRTC connection, this variable is actually over here, but it didn't found it. So this is completed, can be referenced before it is declared. So for some reason my function is not properly working. So in here, this is the function. Okay, so the issue is resolved. So this thing is completed. Now the next thing I want is that I want to create this basically stopping mechanism for like stopping the connection from the WebRTC. So for that I can just use the first of all I can check that if the data channel that was just created, if does not equals to null, then should just close the data channel. Await, this function will be an async function. Await data channel dot close, and should make the data channel as null. The same thing is if the local string is does not equals to null. In that particular case, await local string, make it as local string dot get tracks dot for each, and for each track I'm gonna stop the track. So track dot stop, this will be a function. So this is completed, the local string can be null, so I can use this, and then I can make the local string as null. And the last thing is if peer connection does not equals to null, then we can close the peer connection dot close, and then we can make the peer connection null. Okay, so this is done. I can just print over here, print WebRTC connection terminated successfully. Okay, so this thing is completed. um the last thing we can do is we can set up the data channel. So for setting up the data channel, I can go into this setup remote description. Okay, so in here I can set up the data channel. So I can just simply check that if my data channel is not null, then I can just set up the data channel. So I'll use this function. This is a function that I've just made, so it's a bit easy. So I'll just copy it and paste it in here, and this problem is resolved. In move it. So you can use this setup data channel function to basically get the exact response that was provided by the backend, because there are scenarios where you need to actually print the data or something like that for yourself. So that the purpose of this was that we can use this data channel. So I'll just quickly run this application. So I'll just remove the my homepage, and this is an AI assistant Flutter, and here I can call the main screen. Okay, one more thing I can do is I'll have to do is for the start call I will call start WebRTC session, and the stop call I'll just use stop WebRTC session. And in here, before start WebRTC session is called, I can just call the stop WebRTC session connection. So just in case that if someone uh, presses it again, it will first stop the connection, and then it will create a new connection. So I'll just run this application. So my app is up and running. I'll just click on the start call function. So in here I don't have any I'm using the emulator, so I can't really hear the voice. So I'll just run the application on my phone and check it again. Okay, so one thing I missed in here was that to actually use the microphone, I have to add the properties in the manifest file. So I missed that, and that's why the app won't listen. So in here, I have to basically get the permission to record the audio and record the modify the audio settings. So I'll just add up all these things, and also I can use these. Okay, and then I need to use the permission manager, sorry, the permission handler. Permission, and in the init state, I can request for user permissions. So I will create this function request permissions, void request permission AC, and make it as await permission handler permission dot microphone. So let me import the package. the microphone dot request, and the next thing I want is to call. Okay, so I've already called this function, so I can just rebuild the application and it should work. Soon as the application runs, it's asking for the permission to record audio, so I'll give it, and then I'll start the call. Hello.